the hyperbola. We have the definition, a definition of a hyperbola. A hyperbola is the set of all points xy, the difference of whose distance is from two distinct fixed points, which are called foci, is constant. So this time the difference is constant. The difference between the two distances are constant. In the case of the ellipse, the sum of the distances were constant. But for the hyperbola, it's the difference that's constant. And if we look at figure 4.27, so you have two foci for the hyperbola also. For the parabola, we only had one focus. So here's an example of a hyperbola. You have the two fixed points. Here's the one focus and there's the other focus. Those are the two fixed points. And these two distances, the distance from a point on the hyperbola to one fixed point, and the distance from that same point to the other fixed point, the difference between those distances is a constant. So that if I pick any point, if I pick a point over here, if I measure the difference between, if I measure this distance and measure that distance, and then subtract those two, d2 minus d1, I would get the same number that I got here when I subtracted, when I had d2 minus d1 here. So this might be d3 minus d4, or it might be, since you're subtracting the longer one here, this might be our d3 here, and this might be our d4, or rather this would be our d4. Okay, d4, d3. So d4 minus d3. That difference there would be the same as the difference that we have here in any point that we select. If we measure this distance here, and subtract those two distances, we would get the same number that we got here. So of course, based on this figure here, you're subtracting the smaller one from the larger to get your difference there. So that is the definition for the hyperbola. Now we have special parts of the hyperbola that you have to be able to find. First of all, as you can see here, we have what we call the transverse axis. The transverse axis is the axis on which the center and the foci and the vertex lie. All three of those measurements, all three of those points, or all three of those types of points lie on the transverse axis of the hyperbola. So you can see the transverse axis of the hyperbola, it splits the hyperbola in half. So the hyperbola is symmetric with respect to the transverse axis. The center is located here, and in all the problems that we'll be doing, the center will be located at the origin. So you have your x-axis going through here and your y-axis going through there, if your graph is oriented like this. Now the distance from the center to the vertex is a. The distance from the center to the vertex is a. So you have the same distance from the center to the vertex here as you have from the center to the vertex here. The distance from the center to the foci, or to the focus, is c. That's the distance from the center to the focus. That distance there is c. So this distance here would also be c. So those are some of the important parts of the hyperbola. Next we have the standard form for the hyperbola. Now I want you to look at these standard forms as we did previously, and you can see how they're related to the standard forms for the ellipse. In the ellipse we had x squared over a squared plus y squared over b squared equals 1. But in the hyperbola, you have a minus on one of your terms. Here the minus is on the y squared, here the minus is on the x squared. So you have a minus on one of your terms. You still have 1 on the right side of the equation in standard form for the hyperbola, just like you had for the ellipse. Your positive term here is the x squared term. If the x squared term is the positive term, that means that the transverse axis will be on the x-axis. So here is on the y-axis. So here it would be like this one. You see the y squared is the positive, the x squared is the negative here. But over here the x squared is the positive and y squared is the negative. The one that's the positive is the one that would contain the transverse axis. If the positive is on the x squared, the transverse axis will be on the x squared. So that means that A, the distance from the center to the vertex, will be under x in this case because it has the positive. Whereas in this case, the distance from the center to the vertex would be under y because it has the positive. So we know that the vertex, the foci, the center, they all have to be on the transverse axis. Now, the relationship between A, B, and C. As you can see here, in this case, A, which is the radius for the transverse axis, is under the one that's positive. A is the radius of the transverse axis, and that is under the one that's positive. This is the relationship between A, B, and C. If you're dealing with the hyperbola, the formula is B squared equals C squared minus A squared. This is the formula that you use to find C if you don't know, if you know A and B, or to find B if you know C and A, or to find A if you know B and C. Okay, now we look at the graphs and we can see the relationship between the graphs and the equations. Now, as we said here, look at this. For this equation here, the positive is on the x squared. You see, the positive is on the x squared. We have it in standard form because we have a 1 on the right side of the equation. The positive is on the x squared. Since the positive is on the x squared, look at where the transverse axis is. The transverse axis is on the x-axis. So you just look at the one that has the positive on it, and that will tell you where the transverse axis. And the radius would be from the center, here's the center of the graph, to the vertex. This distance here would be A. This distance here would be A. This distance from here to here would be C. And this distance from here to here would be C. So those are the things that you can see on these graphs here. Now look at this graph here. If you look at the equation, look at where the positive is. The positive is on the y squared term. And look at where the transverse axis is. The transverse axis is along the y-axis. So this distance from here to the vertex would be A. The distance from here to the focus would be C. And of course the formula that we have here is B squared equals C squared minus A squared. Okay, let's look at an example so that we can see an application of this theory. Example 5 on page 367. Finding the standard equation of a hyperbola. Find the standard form of the equation of the hyperbola with foci at -3, 0 and 3, 0 and vertices at -2, 0 and 2, 0 as shown in figure 4.29. So really you could graph these foci yourself. If you draw your x and y axes, -3, 0, you would go from the origin, you would go 1, 2, 3 to the left, and just stay there. The other focus is 3, 0. So you would start at the origin, you would go 1, 2, 3 to the right, 3, 0. So since the y-axis contains the foci, that means that the y-axis, since the x-axis contains the foci, that means that the x-axis would be the transverse axis. Then you can graph the vertex, first vertex, -2, 0. So you go 2 to the left, that would be a vertex. So the vertex is here, so that means, and the graph wraps around the focus. So that means that this graph would look like that. And on the right here, 2, 0 is located here, so the graph wraps around the focus. So this graph over here would look like that. It's a nice smooth curve here for that graph. So that would be how the graph of that hyperbola would look. And if we look over at the figure there, figure 4.29, you'll see that that's the same type of graph that we have there. Okay, so you see these imaginary lines here. These imaginary lines are asymptotes. So these are lines that the graph gets closer and closer to. Theoretically, the graph never touches these lines, but the graph keeps getting closer and closer to these asymptotes. Okay, so that's what we have as far as the graph is concerned. We had to find the standard form of the equation. So if you look at the standard form of the equation, the only thing you need to know for the standard form is A and B. Those are the only two things that you need to know in order to write this standard form of a hyperbola. So if we look at the graph that we produced here, the distance from the center to the vertex is A. So this distance here is A. So we can measure that distance. That distance is 1, 2. So that means that we already know that A is equal to 2. Now, the distance from the center to the focus is C. The distance from the center to the focus is C. So we can measure that distance. That distance is 1, 2, 3. So we have C equals 3. So now all we need to do is find B. And the formula that we use once again is B squared equals C squared minus A squared. That's the formula that we use. B squared equals C squared minus A squared. So we substitute what we know. We know that C is 3. So we're going to have 3 squared. We know that A is 2. So we're going to have minus 2 squared. 3 squared is 9. 2 squared is 4. 9 minus 4 is 5. So we get B squared equals 5. We take the square root of both sides. We get B is equal to the square root of 5. Because here we're assuming that B is a positive number, so we don't have to worry about plus or minus. So now we have everything we need to write the equation in standard form. We know that the positive is on the axis that contains the transverse axis. So the x-axis has the transverse axis. So that means that the positive in our formula is on the x. So we go back and look at the formulas there, and we see that the first formula has positive on the x. So therefore, in this case, for our example, we would have x squared over a squared, and we know that a is 2, so that would be over 2 squared minus y squared over b squared, and we found out that b was the square root of 5, so we would have the square root of 5 squared equals 1. So this would give us, if we write it the way, this would be exactly in standard form, and this is the way I would prefer it. I would prefer it written in that form. but the author goes ahead and squares the 2 there and gets 4, and squares the square root of 5 there and gets 5 equals 1. So this form here is acceptable also, even though this would be more exactly in standard form. X squared over 2 squared minus y squared over square root of 5 squared equals 1. So there we have the standard form of that hyperbola. And that's the answer that the author got there. Okay. Now, there's a nice quick way of graphing these hyperbola. And we can do that by using A and B and making a rectangular box. If you look at this graph right here, okay, if you take A on the transverse axis and go from the origin to the right A, and from the origin to the left A, and then draw your vertical lines, and then take B, go up B and down B, draw your horizontal lines, you have a rectangular box. Now, the diagonals of this rectangular box are the asymptotes. So all you have to do is draw the rectangular box, then put in the asymptotes, and then just draw your graph, because the vertex will be right at that point of a side of the rectangular box, and the vertex will be on the transverse axis. So it will be on the transverse axis, and wherever A is. Remember, in the case of the hyperbola, A is the one under the positive term. Here the A is under the A squared is under X squared. So that means that A would be along the X-axis, because it's the positive one. That would be the transverse axis. Okay, in this case, here the positive one is the Y squared term. So the A squared is under the Y squared. So you can see here that if you go up A and down A, in this case, and then go to the right B and to the left negative B, or to the left B units. Here I meant go up A units and go down A units. Go to the right B units, to the left B units. You can draw this rectangular box right quick, and then after you draw the rectangular box, you draw the asymptotes, and then after you draw the asymptotes, you know the vertex has to be on the transverse axis, and it has to be that point, the midpoint of that side of the rectangular box. That's where the vertex has to be. So then you can just draw the graph of the hyperbola. So graphing hyperbolas are very easy. Now you can get the equation of the asymptotes by using the formulas that you see there. You have two asymptotes here. The equation of this asymptote is y equals b over ax. That's the equation of this asymptote here. You can see how it's slanted. It has a positive slope. The equation of this asymptote is y equals negative b over ax. So as you look at the equation of the asymptotes, you see that they're basically the same, except that one has a negative, the other one has a positive. And it's the same thing over here for the transverse axis on the y-axis. And you have the reciprocal of the values that you had over here, and you get transverse on the x-axis. For the asymptotes, you get y equals a over bx, and y equals negative a over bx. So those are the equations for the asymptotes of the graph. Okay, let's go over to the next page, page 368.